On the Similarity and Trig test review homework, let's look at the last page. Solve the following triangles, which means find all the missing sides and angles. So I usually try to use the information that's given to find each of them individually. You can use other techniques if you would like to find the second and third pieces, but make sure that you used the entire decimals from any earlier information that you find. So, to find PQ, PQ is the opposite side of 37. Opposite over hypotenuse, since I know this side, means I'm using sine. So sine of 37 degrees equals the opposite side over the hypotenuse. So to get x by itself, I multiply the 22 over to the other side. 22 sine of 37. Type that in the calculator, 22 sine of 37. And so to the nearest tenth, that becomes 13.2. So PQ is 13.2. Now to find QR, that's adjacent to 37. Hypotenuse is 22, adjacent and hypotenuse is cosine. So I want to use cosine of 37 degrees equals adjacent over hypotenuse. The bottom number multiplies over to the other side, and 22 cosine of 37 degrees to the nearest tenth becomes 17.6. QR is 17.6. Notice both of those are less than 22, and they add up to be more than 22. Measure of angle P, the unknown angle here, these three angles have to add up to 180. So we could say theta plus 37 plus 90 needs to equal 180. 37 plus 90 is 127. So when you subtract that from 180, the missing angle is 53 degrees. So the measure of angle P is 53 degrees. The next one over asks us to start by finding TU. Well, in this case, we know two of the sides, we're looking for the third side. So we can use Pythagorean theorem. 7 squared plus x squared equals 23 squared. 7 squared is 49. 23 squared is 529. So we subtract 49 from that to get 480, and then we take the square root of 480 to the nearest tenth is 21.9. TU is 21.9. A little less than the hypotenuse. Well, looks good. Next, we're looking for the measure of angle U. Well, we only have one angle, so to find a second angle we have to use inverse trig. So from U we have the opposite and the hypotenuse. Therefore sine of U, or measure of angle U, equals opposite over hypotenuse. Therefore U will be the inverse sine of 7 over 23. Second sine, 7 divided by 23, That means the measure of angle U is 17.7 degrees. Well, once you know a second angle, you can always use that to find the third. I'm going to use measure of angle S, using the sides that I was given to start with, 7 and 23. That's the adjacent and the hypotenuse. So cosine of S is equal to the adjacent side over the hypotenuse. So angle S is equal to the inverse cosine of 7 over 23. Second cosine, 7 divided by 23 to the nearest tenth is 72.3. Measure of angle S equals 72.3 degrees. Notice these two angles add up to 90 degrees. Okay, the next one, we start by finding dm, so I'll treat that as my x. Given the angle, I have the opposite, I'm looking for the adjacent. Opposite and adjacent is tangent. So tangent of 51 degrees is equal to the opposite side divided by the adjacent side. Whatever's on the bottom multiplies over to the other side. X tangent of 51 degrees equals 14. Then we need to divide by tangent of 51, so x is equal to 14 divided by tangent of 51 degrees. So I type that in, 14 divided by tangent of 51 to the nearest tenth, that is 11.3. dv is the other missing side. So, using the opposite side, looking for the hypotenuse. Opposite and hypotenuse is sine. Therefore, sine of 51 degrees is equal to the opposite side 14 divided by the hypotenuse y. Y multiplies over next to the sine of 51, and we divide by sine of 51 so that y is equal to the 14 divided by sine of 51. 14 divided by sine of 51 is approximately 18.0. Notice the hypotenuse is the longest side. Finally, measure of angle V. If we look at those three angles, they have to add up to 180. Or you take away the 90, the two remaining angles have to be complementary. They have to add up to 90. So 51 plus the measure of angle V needs to equal 90. So we subtract 51 to get 39 degrees for the measure of angle V. And the last of these, solving triangles. So we're looking for UM, which is the third of the sides. Therefore, it can be found using Pythagorean theorem. X squared plus 19 squared needs to equal 28 squared. So 19 squared is 361. 28 squared is 784. 784 minus 361 is 423. So we take the square root of 423 to get approximately 20.6 or UM. Notice it's smaller than the hypotenuse. Measure of angle E. This angle, we don't know the other two, so we need to use inverse trig. 19 is the adjacent side, 28 is the hypotenuse. So cosine of angle E is equal to adjacent over hypotenuse. So to get angle E by itself, we have to do the inverse cosine of 19 over 28. Second cosine, 19 divided by 28. The measure of angle E is equal to 47.3. Finally, measure of angle U. Again, we could make these two angles add up to 90 degrees so that all three angles add up to 180. Or we can use the fact that U is opposite 19 and 28 is the hypotenuse. So this means that sine of U is equal to the opposite divided by the hypotenuse. So to get U by itself, we do the inverse sine of 19 over 28. And so the measure of angle U is equal to second sine of 19 divided by 28, 42.7. 42.7 degrees. So that's solving the triangles. So now we go to some with word problems. In number 21, John wants to measure the height of a tree. He walks exactly 100 feet from the base of the tree and looks up. The angle from the ground to the top of the tree is 33 degrees. How tall to the nearest foot is the tree? So, I need a tree. There's my tree. John wants to measure the height of the tree. The height of the tree is what we're trying to find. He walks exactly 100 feet from the base of the tree and then looks up. The angle from the ground to the top of the tree is 33 degrees. So how tall to the nearest foot is the tree? Well, the x is the opposite side, the 100 is the adjacent side. Therefore, tangent of 33 degrees is equal to opposite over adjacent. Multiply the 100 over to the other side. Type in 100 tangent of 33, and it's how tall to the nearest foot. So it's 64.9, which means it goes up to 65. How tall to the nearest foot is the tree? The tree is about 65 feet tall. Number 22, an airplane is flying at a height of 2 miles above the ground. So here's my lovely plane. It's flying at a height 2 miles above the ground. The plane must travel another 10 miles before it lands at the airport. So this one's a little tricky to interpret. Does the 10 miles mean along the ground, 10 miles in distance along the ground, or is it the actual plane that must travel those 10 miles? I think it would be very easy to have included something about 10 miles along the ground or from right below the plane to the airport. And so I think the plane itself is traveling 10 miles, means that this is decreasing or traveling 10 miles to land at the airport. Therefore, what is the angle of depression from the airplane to the airport? So angle of depression is this angle between the horizontal and the line of sight going down, or the direction the plane is traveling going down. So the angle of depression, because it's alternate interior angles, is the same as the angle of elevation from the airport up to the plane. So that's going to use the opposite side and the hypotenuse. Therefore, sine of the angle is equal to opposite over hypotenuse. Therefore, we need the inverse sine of 2 over 10. Second sine 2 divided by 10. Theta equals 11 point, it says, let's see, to the nearest degree. So 11.5 means that it's actually going to be 12 degrees. So what is the angle of depression? The angle of depression is 12 degrees. Number 23. A wooden beam 24 feet long leans against a wall and makes an angle of 71 degrees with the ground. So we've got our wall, and there's a beam leaning against it. The wooden beam is 24 feet long. It leans against a wall and makes an angle of 71 degrees with the ground. So the beam makes the angle with the ground. How far apart are the bottom of the wall and the bottom of the beam? So how far is it from here to here? There's my unknown. So based on 71 degrees, I'm looking for the adjacent, but I know the hypotenuse. So cosine of 71 degrees is equal to adjacent over hypotenuse. Multiply the 24 over to the other side. And then we type in 24 cosine of 71. That makes x. Let's see, how far apart are the bottom of the wall and the bottom of the beam? It doesn't say what to round off to. So we'll go to the nearest tenth. 7.8. how far apart are the bottom of the wall and the bottom of the beam? They are 7.8 feet, since it's 24 feet long. They're 7.8 feet apart. And the last one, a suitcase measures 24 inches long. So let's get our suitcase. We'll ignore the handle. 24 inches long and 18 inches high. What is the diagonal length of the suitcase to the nearest tenth of an inch? Well, assuming this is a rectangular suitcase, which seems to be based on length and height, that means we're set up for a Pythagorean theorem. So 18 squared plus 24 squared needs to equal the diagonal squared. (18 squared is 324. 24 squared is 576. Add those together, and you get 900 as the length of the diagonal squared. So we take the square root of 900. Square root of 900 is 30. So what is the diagonal length of the suitcase to the nearest tenth of an inch? The diagonal length is 30 inches. It is longer than the both legs, so that seems like a reasonable answer. Please let me know if you have any questions on any part of this review guide, and happy studying.